It's so now right before lunch, I have the opportunity to make sure that we keep you interested in the application of data. And by show of hands, when you think about John Deere, do you think about green tractors? Yeah. So the key point here is we're a little more than that, and I hope to get that message across here during the next bit of time here. Help me with the interface, user interface here on this. Okay. I want to start with a video, if I can get this right. And this will, no, I got the wrong one there.
Farmers have been collecting information on their operations for years.
Okay, let's go right into the presentation. I'll apologize for that. I was going to show you a video that that started with you can Google it. It's on YouTube called Farm Forward John Deere. You can look at it. It was a video that we produced about 3 or 4 years ago to give an idea of where agriculture can go, and so it was really kind of a 10-year vision, and maybe where agriculture could happen, and this business that's really been an art for a number of years that has stayed in many of the same hands, the same farmers who farm year to year, know their farms pretty well, and it really would start to paint that picture that says it can go from an art to a science, and eventually to a lot of the math, the modeling type of work that you've already heard about this morning. So that video, you can take a look at it in your own time here. So what I want to do is spend just a little bit of time and talk about the technology applications. It's going to show some technology, and we're going to show applications of data. So we'll get a good mix of both here during the next 30 minutes. And just to give you a little bit of an evolution of technology for ag, this slide depicts that really technology about guidance systems. Belinda talked earlier about her GPS wasn't accurate enough. Her son was talking about this. We have GPS accuracy that can get down to less than 2.5 centimeters to place the seed, the fertilizer, next to the seed where it needs to be. Not only this year, but next year and next year. That's the kind of accuracy capabilities that our equipment can do, so that we get more precision in agriculture. And that's the guidance of our machines, the control of machines is pretty well adopted. If you look at all large ag machines, that is almost as standard as cruise control is on our cars. This next evolution of technology, this precision farming space, is maybe a little less adopted, where we start to get into precise measurement of what's on the field, some of the things that Jeffrey talked about, and what is coming off the field. There's been a lot of data that's been looked at and used and compiled in books that many times we talk about this data being held hostage, either because it's on thumb drives or it's in the computers that are in our tractors or combines, but is not being used. And I'll show you a slide a little bit later on of what that adoption really is. And that data then can be used to start to manage on a precise basis the variable rate applications, placing the right seed, the right hybrid, at the right population, at the right depth, so that we get that maximum yield capability. Finally, the adoption of telematics is really just the wireless technology in agriculture hasn't been there until just the last 3 or 4 years. And that promises a great opportunity for us to start to get to this point where data isn't held hostage. So I wanted to give you a slide that really depicts our technology space that we've been about for some time, really for almost 10 years now, where we can make straight rows in the field, and we can shut off planters so that the end rows here are not all fields are square. If you know a little bit about the farming business, where the planter can then be shut off as the rows come and need to shut off at the right time. And that's all done with GNSS technology capabilities, our satellite feed. So a nice field like that. And you say, well, is that really important, or is that a novelty? I can tell you, and if you've had experience on the farm, when you start to get rows that plant over top of each other, they become weeds. Corn is genetically bred to be at a certain spacing and not overlap. And likewise, if we had spaces in the field where we don't have the crop, then of course we start to negatively impact yield. So these kinds of technology, not just placing the seed, but also putting the chemicals in the field or other fungicides and so forth, can be controlled with this kind of precision. Again, down to the sub-inch type of capabilities. What you'll see in my presentation here is a strategy we call Farm Sight. It's really a vision that says what we're going to use data for. And we're going to use data to optimize the performance of our machines in the field. And that's a critical component because of the history that Deere has and the number of machines that are in the field to get the maximum use of those machines already operating. Tremendous amount of inefficiency happens for whatever reason, some of the variability that is most of which can be controlled. Logistics and job optimization, it is the actual task or the work that's being done in the field. Real-time information that comes that says this portion of the field is not the same soil characteristics that another portion of the field, and I want real-time data to come and now place the seed at the right depth based on the data that comes back. Those kinds of job optimization opportunities is another space where we'll use data. And finally, ag decision support, and this is about making decisions much easier. And we got this word support in there. There's a lot of folks that are our stakeholders in the industry, the input providers that provide the seed, the fertilizer, the retailers that are making the agronomic recommendation. And ag decision support provides us the ability to collaborate and work with all those stakeholders in the industry. It's the same 3 pillars depicted on this slide, but now I want to depict this in a way that starts to illustrate the entire season, from the time I till and prepare the soil to the time I'm planting the seed, nurturing the product, the corn, soybeans, whatever the crop is, and then finally harvesting. Our intent is to apply this across the entire farming season for our customers. So I mentioned a little bit earlier this data that's being held hostage. If you look at this graph, the yellow line depicts the number of planters that have been shipped from our factories that had the capability to variably rate change the population, to place seeds closer together or further apart based on the parameters that are critical to seed spacing. But on the green line, it's the adoption of variable rate, the actual use of variable rate. A lot of farmers got it just to change from field to field, but not within the field. So really many reasons why. complexity is normally the first thing that comes about. The second thing that comes about why the adoption hasn't been greater is just the confidence that it's going to make a difference. Jeffrey talked about some of the controllable items, variables that you have, but you got the uncontrollable ones too. And so you have farmers that would say the uncontrolled ones will be dominant here and have an adopted variable rate. We do believe that's going to take a rather steep incline now that it's going to be much easier to do. The other thing that this is meant to depict the complexity that's happening on farms today. Back when I grew up on a farm back in Ohio, it was 272 acres. We milked about 100 cows. My brothers continue to milk there. But at that particular time, we did everything ourselves. The farm wasn't very large. As our farmers have gotten larger to 1,000 to 10,000 or even larger acres, the number of stakeholders that they depend upon and the complexity that they deal with throughout the year is enormous. And this starts to depict this a little bit. I used a slide at a conference once, and it came from the audience. It was all farmers in the audience, and one of them hollered out and said, "Yeah, after we get all that done, we go in for breakfast." So the point really here is that between the process quality and the ability to use data to make our farmers' lives much easier, it's there. The opportunity is there to start solving for some of these challenges that they face. So Deere back in 2010, starting with machines that started shipping in January of 2011, on our large ag machines, we began starting to ship every one of them with a wireless device on them. So this depicts only the agricultural products, but also our construction products all go out with data collectors on it. This data collector is happens to be a cellular modem, so we're dependent on rural broadband very heavily, but we could also put a satellite modem on these machines as well. We've got hundreds of thousands of machines every day who are calling in, and we're collecting data from the machines, mostly about the machine performance, the machine health, where it's at, the applications that are taking place, and again on our construction products as well. So since 2011, that's been the mode of operation. I will tell you the reason that we got serious about getting into this area was emissions control. Off-road emissions took a significant point of control in 2011, and the final emissions was in 2014 for off-road vehicles, to really get to a point of, and I say this often, is that the emissions that our tractors could be running in a very smog-filled area of an inner city, what comes out of the exhaust is cleaner than what's going in. So, but we wanted to make sure we could control that and have data to be able to give that back and have the ability to see when problems may occur. This system is set up well enough that if I had a tractor and I knew that I wanted to be sure that it wasn't getting to a certain temperature, or the engine at a certain oil pressure, I would get a text alert that says, "Hey, you've got a challenge with your machine, you need to address it." So let me go back to the three areas of value that we think we can deliver from data, and also the technology space, because it's wonderful being an innovation center here that we depend on very heavily around innovation, not only on data but in machine technology. First, it's just monitoring these machines, sending alerts when things are happening real time, but also collecting data and being able to start to understand that data in such a way that we can get to a point of starting to predict before a failure occurs. So it's very important for us to have The image of John Deere is typically high reliable machines. But today, for us, when we find out when a problem does occur in the time that we know about it in the field, without telematics, can be rather significant. And we've cut that down significantly now when we start to see issues start to happen, and we can get problems out to, or solutions out to farmers before they've actually experienced it. So where are we at in this whole machine data information journey? You could see, and excuse me for the acronym MKC, it's our Machine Knowledge Center. It's where our data is compiled, and we have the ability to put out a number of health reports, look at emerging issues that are taking place, and actually where our capabilities are is about at this point. We're at a point to say what will happen, and eventually we want to get to a point of saying how can we prevent machine failure before it does happen. So you say, is that really critical? I can tell you Uptime is one of our most highly valued pieces from our customers. And many times, because our machines operate in a system, we're talking about thousands of dollars per hour that could be costing farmers if downtime time is in place. Secondly, this whole job optimization, machines really working together to increase productivity, the system of the farm, not just the individual machine. A number of solutions that can take place here. Also diagnosing machines in the field, remotely dispatching into the machine to look at knowing when a failure's taken place. We can take from our dealerships to look at the diagnostic codes that have been thrown off the machine before we go out to the field and actually diagnose it in the field. That way the technician has the capability of having the right parts, the right equipment to fix the problem. And finally, this ag decision support area, it's about building a data platform that is a capability of being an open platform to share data where farmers choose to share data. So if he wants that data to go to an agronomist who's going to make the recommendation, that our platform can do that today. So again, customer controlled use of data. So this is simply an illustration of the machines on the farm and how we are collecting data, both the machine data, and I heard the question asked earlier about yield data, and also the as applied data. What's being applied, in other words, the seed population in the field, and the spacing, and the chemicals that are going on the field. All that data can be collected and stored at MyJohnDeere.com platform. And you can see on this platform, I've depicted this with certain locks, because really the only person that has access to this data is the farmer. And he can then unlock and decide who that data should be shared with. It may be an input provider, maybe other software companies that will add value for him, or it may be the John Deere dealer who can put together some machine services capabilities for him. This data platform today, we have a number of partners already on it, from retailers, input providers, and for sure the John Deere dealer as well. Certainly meant to depict every portion of the growing cycle from planting to all the way through harvest, from tillage to plant to nurture and harvesting. So let me maybe get a little more specific as you look at the kind of work that the group that where I'm at, we're called the Intelligent Solutions Group, or isolated in a group. I admired Tim for being up here in blue jeans. That's the kind of office environment we're at. And you think about John Deere, and if you go to one of our factories, and you'll see in our offices a business attire most of the time. The guys that I'm around all day, we have a very Google-like office. So it's one that we spur and want to make sure that we have every opportunity for good data, for good innovation kind of thinking. And this is a good example. Within our cab, we talk about inside our operator station, from the cab itself to the cloud, we want innovation to take place. This is not too untypical. We have a project that's very much live with integrating displays that has a common user interface between tractor to combine to sprayer, and where we're collecting, again, machine data and also field data. We also have a number of applications that I'll show here that utilize consumer devices that help us with more granular capabilities of data analysis. This is an example of what we call SeedStar Mobile. As you can see maybe on the slide there on the top, we're looking at singulation capabilities of about 99%. We want to know when that planter is planting, do we have any outliers? And you can see in this illustration that there are some outliers, and decisions can then be made to start to say what's causing the problems for seed spacing in the field. But a number of other things can be also depicted as we go through the field to be sure that we get the granular capabilities. In general, for most of our yield maps that have been collected over the years on thumb drives, the data space in the field is many times at about 1,000 square foot level of granularity. And today we're going down to more of a fraction of that, a row by row and a plant by plant kind of capabilities. The capabilities for the high definition applications will go across the production cycle. We haven't fully introduced all of these. We will in time, but I illustrated the plant that is out there in the marketplace. We'll have harvest granularity. We'll have spray or protect granular data sets. We'll have tillage applications that know exactly what's been done to the field. So those are be onboard, inboard to the cab, and also data that is sent to the cloud. In the sense of starting to look at now what's being done, what's the work being done, the illustration here of building MyJohnDeere starts to depict the work that's being done. If you can read the slide, you see that certain fields are completely done. Certain fields are 11% done, as shown on the depiction here, in yield that's come off of that field. How many bushels have I received off of that field? I have an employee who also farms in Illinois, and he's all the time, he's a remote manager, and he could be in Des Moines, Iowa, where we're located, and see what the progress of his operation is taking place, so that he can make the right decisions about his farm. This data can then compare hybrid by hybrid, or field by field in yield information, also the as applied information, knowing what's in the field, so that analytics can be done on the data sets. So a yield map, or even an as applied map, you can start to layer the individual data sets and start to understand more about what's going on in my fields. If you looked in the past, my dad, as he farmed, he always knew what was taking place at one end of the field versus another. But today's farmers, as they grow and are on ground that they haven't been in the past, they're farming more on a data basis here. I've mentioned that our platform is about partnering, and I depicted that earlier with farmers sharing data at their choice. We look at our machines as the data collectors in the field. We have them on machines. We also have a number of other data sources, other sensors. For example, to get precisely what's under the ground, we use soil moisture sensors that depict how deep the moisture is and how much moisture is in the ground, wirelessly sending that data to MyJohnDeere so that then decisions could be made. But this all goes into the database enough here that starts to assemble and manage that information, and then the yellow spots here start to get to the point where farmers share data and use trusted partners. And then it gets applied back to the machine. And that's what's important. If you look at the farm cycle, is what we get off the ground makes into decisions the following year to start to make applications and changes in the operation for the next season. And how I till the ground may impact how I want to plant the ground, may impact how I want to spray and take care of the crop throughout the season, and then harvest as well. Many farmers are starting to go to multiple hybrids in the same field. It would be very good information. Most hybrids don't harvest the same way. For the harvester to know where each of those hybrids are, so that as it's coming through the field, it automatically adjusts to take into account the new hybrid that's in the field. Not there yet, but that's kind of painting the picture for some applications in the future. Again, it's certainly the image of Deere is about equipment. We'll continue to provide the products in the field, but we're going to enhance those products through technology, and with the finest dealer network in the business, offering the kind of support and services for farmers is really critical for us to see the value and for farmers to increase yield. And I want to depict this. We look at our role as John Deere to think about the impact to our farmers' top lines and bottom lines to improve the performance of our equipment, the uptime of equipment, the cost that are taking place in the operation, and to help improve yield. If our planters can plant the seed at the right depth, the right spacing, and impact all of these items here, we'll get farmers to drive more money to the bottom line. So this is a little bit of a summary slide that depicts really the farm site strategy. Again, the three areas that are a focus for us. Really around machines, to get that machine operating the best that it can. I'll give you one example where inefficiencies take place. Large sugarcane operations in Brazil, and owned by large corporations that look already to get maximum efficiency out of their machines. And so the plan is to harvest 24 hours a day, harvesting sugarcane that is then used in ethanol use applications. When the farmers started measuring the efficiency of what that sugarcane harvester was actually doing, it was about half of that time. Only about 12 hours of the 24 hours was it actually harvesting. The reasons for that are varied, and until you have the information, can decisions start to be made. It may be a logistics solution. It may be a machine uptime issue. It may be a number of things where quality of operators is often the issue. So what we're able to do over time is begin to improve the efficiency of those kinds of applications. So as our farmers get larger, the value that's going to be delivered here and the value they'll realize will be significant in coming years. I also wanted to mention this doesn't just apply to our agricultural side. I spent quite a bit of time talking about that today, but also on our construction equipment. Much of the same way: machine health, machine productivity, job site optimization, and also services from our dealers. And if you see farm publications, advertising, this is we use the John Deere Farm Site name as part of this whole strategy, really how we intend to bring more value from the use of technology and data in our products and through our dealers.